So this is the first of two short lessons, just kind of introducing some exponent laws, which really just means some properties when working with powers. I guess you can think of it as shortcuts, ways to kind of speed up working with certain types of powers. And so for example here, I have 2 to the power 4 times 2 to the power 3. I'm multiplying two powers that have the same base. They both have a base of 2, but they have different exponents. In this case, if I think about what this means, 2 to the power 4 means 2 times 2 times 2 times 2. I'll use a dot, it's a bit faster. And then times 2 to the power 3, which is 2 times 2 times 2. So 4 2's over here, 3 2's over here. Well, again, I don't really care about evaluating this. I just care to realize that in the end, I have a total of 1, 2, 3, 4, 5, 6, 7 2's being all multiplied to each other. So this must be the same as 2 to the power of 7. Well, in the end, while this is totally correct, I really didn't have to write it out as repeated multiplication to figure that out. I could just, in the end, I could realize that all I really have to do is add my exponents together. 4 plus 3 is 7. And so in general, if I have two powers with the same base but different exponents, then I can always write this as a single power with that one base, a base of a, whatever the number is, and just add my exponents, x plus y. So what I have here is a way of just generalizing this exponent law. And again, it may look a bit more abstract, or may look considerably more abstract, this compared to this, but it's summarizing the same idea. And again, way more important than just trying to memorize some formula, because again, it's not really meant to be a formula. This is just kind of summarizing this exponent law up here, that when you're multiplying two powers of the same base, if you want, you can add your exponents together and write as a single power. So what if you're dividing? Well, same sort of idea here. Notice I have two powers of the same base of 2, but now one has an exponent of 5, one has an exponent of 3. So one thing I could do is think of it as 2 times 2 times 2 times 2 times 2. That's 2 to the power of 5. All divided by, right as a fraction, 2 times 2 times 2. That's 2 to the power of 3. Well, while I could actually evaluate the top and bottom now, I could also realize, I'm multiplying by 2 in the numerator, but I'm dividing by 2 in the denominator. So why don't I just cancel those two out? Same thing here. Why don't I just cancel these two 2's out, and why don't I cancel these two 2's out? Again, why multiply by 2 just to divide by 2 the next step? So in the end, all I really have left is 2 times 2, or 2 to the power of 2. And the most important part is realizing that I could have got the same thing by just subtracting these two powers. So anytime you're multiplying two powers of the same base, you can add your exponents. Anytime you're dividing two powers of the same base, you can subtract your exponents. And I can generalize that like this. So if I have a to the power of x divided by a to the power of y. What is a? I don't really care. It's just the same number. And I have a power or an exponent of x and an exponent of y. So anytime I have this, if I want, I can write it as a fraction. I can write it as a to the power of x divided by a to the power of y. So these are just two different ways of saying the same thing. But what's the exponent law? If I want, I can write this as just a to the power of x minus y. So it doesn't matter if I think of it as a division symbol or as a fraction. It's all the same thing. Anytime I'm dividing powers of the same base, I can subtract my exponents. And that's what this is really saying here. And one more I want to look at for this lesson. What if I have a power raised to another power? Here I have 2 to the power of 3, and all that's being raised to the power of 2. So what does that mean? Well, this means 2 to the power of 3 times itself twice, 2 to the power of 3. And what does this equal? Well, I could just think on the first exponent law we looked at. I'm multiplying two powers of the same base. So if I want, I can write this as a single power of 2 with an exponent of 6, 3 plus 3. And again, what's a kind of way I can what's a shortcut to this? Well, in the end, I realize I can get the same thing by just multiplying my exponents together. And that'll, again, always be true if I have a power raised to yet another power. And so I can summarize this like this. I have a to the power of x, and all that's to the power of y. So in the end, this is always going to be the same as just a to the power of x times y. I'm not using a times symbol like an x because it looks like an x. Let's put a little dot there. Always, always, always equivalent. So there's a lot more exponent laws, but these are the three most basic ones, and honestly, most important ones. And again, for each of these examples, we have a concrete example and then a sort of generalized algebraic statement. But they're all very, there's only three of them. All right? And try to focus on the idea of why this is correct instead of just trying to memorize something like this.